Good evening, everyone. Are you able to hear me okay? I'm delighted that you're here. I'm Michael Stafford. I'm the director of the Institute of Science at Cranbrook. And on behalf of not only the Institute, but all of Cranbrook, we're so pleased that you actually would forsake a baseball game and a really nice night to come to Cranbrook and actually to hear what's promises to be an absolutely fantastic lecture. And this is the first installment, by the way. You've all, I hope, have received this or seen it. What's so great about the Great Lakes is the series. It is 6 parts. It is done in conjunction with our friends at the Nature Conservancy here in Michigan. So this is a kind of a new foray for us. You may well be aware that the Institute is in the business of freshwater education, largely for Michigan's K-12 audience. And if you do have this with you, or when you get home, you might notice that little freshwater forum symbol on the top. That is the umbrella of all of the initiatives for freshwater activities and education that we now do here through Cranbrook. And we're delighted to have an affiliation and a very, I think, productive partnership with our friends at the Nature Conservancy. I'd like to acknowledge Helen Taylor, who is the state director. Helen, raise your hand and stand if you would, for the Nature Conservancy in Michigan, and also oversees the Nature Conservancy's Great Lakes efforts. They are great partners. If you don't know the Conservancy, we'll hope that you will take time. They have a number of their folks here this evening, and you will have plenty of opportunity to interact with them, both tonight afterwards or at one of the other upcoming lectures. This series also would not happen without some sponsorship help. I want to acknowledge our friends from Northern Trust. Patrick Jakeway and Stephanie Lee are here tonight. If you want to acknowledge yourselves, please. Northern Trust in Bloomfield Hills has been a longtime supporter of the programs that we do here. Fred Adams, the chair of Northern Trust, Michigan, is on our board, and they've been stalwart supporters of everything that we do at the Institute of Science, so thank you again. And we have lots going on. Just as one final plug, I hope you might have had a chance to walk through that open corridor down by where we were all gathered. There's a brand new exhibition that's installed called Extreme Deep. You're going to see a bunch of billboards go up all over southeastern Michigan. It is on the Great Lakes. It's on the history, shipwrecks, and environment of the Great Lakes, as well as deep ocean exploration. It'll be here until June. It's fantastic. So come see it for yourselves. If you have young people in your life, bring them along as well. But it will have a program series that goes with it that is in partnership with the Thunder Bay National Marine Sanctuary up in Alpena. So if you like this kind of thing, there'll be plenty of opportunity for you to spend time in this auditorium, and I hope you'll consider it. But tonight we have, to kick things off, Dr. Patrick Doran. He's the Director of Conservation for the Nature Conservancy in Michigan, and he leads the conservation programs including the protection, restoration, policy, and science activities, and ultimately the implementation of efforts to conserve Michigan's forests, coastal, and aquatic systems. Dr. Doran earned his doctorate from Dartmouth, where he studied the causes and consequences of spatial variation and the distribution and abundance of forest-breeding songbirds. And I should tell you, I have a beautiful Baltimore Oriole sitting on my desk, Patrick. I almost brought it, just sat it on the podium for you. He also has dual master's degrees in ecology, environmental science from Indiana University, studied the effects of forest fragmentation on the breeding success of forest-dependent songbirds, and has an undergrad degree from Villanova. Patrick has held positions as a habitat biologist with the Washington Department of Fish and Wildlife, and has been a senior ecologist, GIS analyst at the Wildlands Project. And I really like this last part. In his life outside of the Conservancy, Patrick enjoys every possible minute engaged in some kind of outdoor activity. Helen, I would expect your scientist to do no less, particularly activities with his wife Heather and their 2 children, Griffin and Carly. So please join me in welcoming Dr. Patrick Doran. Patrick.
All right, is this on? Can everybody hear me well? All right, so I'm going to make a couple apologies first. I'm a scientist. I'm going to be a little geeky. I'm going to show you some graphs. I'm going to show you slides and charts. I will try to explain them, but if I can't, raise your hand or throw a napkin at me and I'll do it again. Now, I'm going to apologize for you. I know come about 8 o'clock, some of you are going to turn on your phones and look down and look at the score of the Detroit Tigers game. You know, don't try to hide it. Just do it. Do it out in the open. If something good happens, you can just let out a little whoop. I'll assume it's for me. So yeah, don't be shy. because I'm not shy. Well, thank you very much for the introduction, Mike. It was very kind. I am going to talk about climate change today, and I'm going to talk about it from a conservation perspective. I work as a director of conservation for the Nature Conservancy. I care about nature. I care about biodiversity. I need to be concerned about climate change. I need to think about it in all the work that I do every day. I'm not going to talk about other things about climate change. I'm not going to get into the politics of it. I will not talk about impacts of climate change on human health or education or transportation or all those kinds of things. I'm going to talk about the interaction of climate and nature. So that's one caveat. I'm also talking about climate change. Some people say global warming. You know, that's a word I'm not even sure I ever really use because it's so much more than warming. So I'll give you some of the, there will be some jargon in here. I'll take a time out halfway through the talk and kind of explain some of those things. So those are a couple things up front I just wanted to warn you about and let you know that, hey, it's okay to look at your phone. Just don't let it ring. So, and I also I always need to start with some thanks because I'll forget them if I don't at the end. I'm going to talk about a lot of work today that has some great partners and funders behind it. Mott Foundation, the Donnelly Foundation in Chicago, the Kresge Foundation, National Science Foundation, and all the suite of partners over here in Cranbrook as well for having us here. So I think this is a great event. I'm very excited. I'm very excited to see the next 5 talks. But I also want to make sure that this work I'm talking about today is not me, maybe just a tiny fraction of me. It's the great staff and colleagues we have at the Nature Conservancy. Katie Call is here tonight. She's one of our conservation biologists that works on climate. This is the work of dozens of people, of my staff and friends and colleagues that do incredible work, and then I look at them with pride and a little bit of envy and jealousy sometimes too, because they do really wonderful, awesome work. So one thing, I get to talk about climate change, and I get to do these talks probably every few months. And one of the first things I do is kind of go to Google and I do a little news search on climate change just to see what the latest is. Believe it or not, I don't read for climate change every single day, but I want to see, you know, what's going on? What are the highlights in the last? Well, this is the big one in the last few days, right? Climate change not mentioned during any of the debates. Interesting, I'm not sure why. I might have some ideas why. Just recently, October 15th, the Pew Research Center came out, and they do a survey every couple years that talks about kind of people's attitudes towards climate change and what's the current status of what people are thinking about in terms of climate change. Well, you know, back in 2006 here, 77% of the people felt that, agreed with the statement that there's solid evidence that the Earth's average temperature has been getting warmer. That dipped in 2009, but the finding in 2012 was there a rebound. And that was people who believe that the Earth is warming, and this is a line of people who believe that there is an anthropogenic cause behind that. And again, so we had a high level and a bit of dip and another peak in that. And that goes across ages and politics and whatever. You see the same pattern. That was one thing. 2 other things in the news. One's a little bit old. I put CocaCola up here that tackles climate change. Levi Strauss, this just came out in October, early October. They had an organization-wide climate change strategy, Levi Strauss and CocaCola, and he's kind of like, well, why? Why do you think they are thinking and working about climate, wondering or worried about climate change? Well, both of these companies, right, rely upon natural resources, water, cotton, and they want to make sure that those resources are available and able to be utilized for their companies and for their products well into the future. We work with Coca-Cola in the Paw Paw River watershed down near Paw Paw, Michigan. If you ever get over that way, Coca-Cola has a bottling plant there. They bring juice concentrate up from, I think, Florida, and they bring the juice concentrate up there and actually add the water from the Paw Paw River watershed to the juice, and that's a distribution center for their juices. They want to make sure that their investments in that factory and that plant are there well into the future. They want to make sure water exists well into the future, and they're thinking about conservation now and climate change now to make sure that they practice they can implement to help ensure that water is there well into the future. So that's kind of interesting. Levi Strauss, one thing on this article is that didn't get a whole lot of press. You didn't hear about Levi Strauss in the Washington Post or the Detroit papers or the New York Times. That's a major corporation in the United States that came out of climate change, and it didn't make the news. Not that I'm saying that's bad, but maybe, just maybe, it's becoming a common thing that we think about every day, and it's really not big news. Maybe it shouldn't be in the debates. Maybe it shouldn't be in the newspapers every single day. Maybe aspects of it are, but maybe it's not the highlight. Because I think and I hope that we are thinking about it every day in the investments we make in nature and investments that some of you make in your businesses or your corporations or your towns or your municipalities or all your actions. It's also hitting home. I don't want to make it think like it's, global or Levi Strauss. This is Chicago. We've had some of the dry summer helps push Lake Michigan water levels to near record lows. I'm not pretending, and I'm not going to tell you that's a climate change impact. I don't know. But I do know we had better be ready for a future world where lake levels can fluctuate widely, even larger fluctuations than we've ever seen over our lifespans over the last 100 years. We had better be ready for that type of impact. I don't know if that's exactly, I can't say that exactly this year is due to climate change. It might be, but we better be ready for things like that. And today I'm going to talk about how we manage and how we think about our natural systems to prepare for impacts like that. All right, so stepping back a little bit about the Nature Conservancy. I realize some of you don't know about me. You heard an introduction and may not be familiar with the Nature Conservancy, but we're a global organization. Our mission is to conserve the lands and waters on which all life depends, people and nature. Our vision is to leave a sustainable world for future generations. We work in all 50 states. We work in over 30 countries around the world. We have over 1 million members. We have conserved lots of land. We are known for our preserves, but we do much work beyond that. Our goal in the Great Lakes, where we have a number of state chapters surrounding the Great Lakes, is to gather together around these Great Lakes, get excited about these Great Lakes, and we want to ensure the Great Lakes watershed is among the most effectively managed on Earth. Within the Great Lakes region, within Michigan and both the Great Lakes, we work on watersheds, kind of the watersheds you see in the southern part of the basin, agriculturally dominated, where we have lots of cities and towns and a high human population. We work in our northern forests, which you all visit. We work on coastal and nearshore areas, and we work on aquatic food webs. These 4 major systems, major drivers of the environment in which we live in this region. We also work on 2 pervasive impacts to that. Sometimes we call them threats, aquatic invasive species, and we have strategies to address climate change adaptation, which I'm going to talk about today. We have a suite of work and a suite of places that talks about all these things, not just in natural areas and areas that are set aside primarily for biodiversity, but we also work on these things on the managed landscapes. We work in northern forests focused on industrial forests and non-industrial private landowners, as well as lands that we own. We work in watersheds in agriculturally dominated landscapes, working with the farmers that need to manage their land to their benefit and the benefit of nature. So, getting back to the news, we had a little blog post out there for some of you to see. Hopefully, or I'm sure many of you really noticed the high price of cherries and apples this year. Right? Well, the big problem with cherries is that we had this wonderfully warm springtime, February, March, if you remember, right? Well, that's just when the buds would burst out. And that spring kind of triggered that burst out. And then we got whacked with some nice cold weather, and a lot of those buds died. And again, I'm not going to say that a failure of some of our cherry crop this year was a climate change impact. I don't know. Maybe, highly likely. I'm not exactly sure. But I do say that climate change will predict, our predictions of climate change in the future, predict warmer springs. And events like this will be more common. And we had better be prepared for things like this. And we better be thinking about the investments we make in the cherry crops, or how we breed them, or how we develop new crops that can withstand those spring temperature fluctuations that may be more than they could in the past. Because if you plant a cherry tree today, you're doing it for the next 50 years. You're not doing it for the next 5 or 10 years. So, 2 major philosophers. Does anybody know who this is? Come on. Pardon? Okay, this is Heraclitus. Anybody ever hear Heraclitus? Yes, please, 1 or 2 people. This is like the only thing I remember from undergraduate education. I mean, really, I don't remember a whole lot. Helen was a philosophy major, so she knows who that was. Anybody know who this is? David Bowie, yes. All right, these are 2 major philosophers of time. They both agree that change in the world is the baseline. It is what we live with. Heraclitus, this is his famous statement. I was going to put it up in Greek. Did anybody read Greek in here? I could have put it up. Some of you would have known. Everything changes and nothing remains still. And you cannot step twice into the same stream. That's really the only thing I remember from undergrad. You can't step twice in the stream. These are also famous aquatic ecologists. David Bowie. I watch the ripples change their size but never leave the stream. That's the same thing. They just said the same 2 things. We see change every day. Some of the world around us somewhat remains the same. We still have water, we still have streams, but they are never the same. Change is what we see every day and what we need to be used to. Sometimes it's always fascinating. I talk to my dad. I grew up in Northeast Ohio, and every time I go home, it's like, Patrick, there's not as many robins as there was last year. I'm like, well, Dad, you know, robins sometimes here's a lot and sometimes there's not. And I'll go back the next year and say, Patrick, there sure is a lot of robins this year. We got to get used to that change. We will not see it. I know we all like to have our cottages on the lake and like to have lake levels right there every single year. That's not the way nature works. I know a lot of people like to go out on their 40-acre woodlot and go hunting. I know they like to see 5 deer every year and shoot one. You know what? Deer populations go up and down every single year for all different kinds of reasons. We have to embrace that change. That's what ecology is all about. That's why I'm an ecologist. That's why I love it, because it's a study of that type of change. Change is the basis. So I'm going to talk about some of the changes we see. I'm going to talk about changes at a global level, and I'm going to talk about some changes in Michigan. And again, I'll show you a couple things. At the top is global average surface temperature. Again, this is over from 1850 all the way up to about year 2000. And global average temperatures on the top, global average sea level, northern hemisphere snow cover. All right, so these are some kind of big numbers across the world. Global average surface temperatures increased about 1.3 degrees Fahrenheit in the last 100 years. Global average sea levels increased 6 inches in the last 100 years. Doesn't seem like that much, but if you're an island nation or if you're Florida, you're paying attention to those things. Arctic ice is shrinking about 2.7% per decade since 1978. Those are some shorter time spans, but still we see these trends. Again, things change. I'm not telling you why they change. I don't necessarily know why they change. I have some ideas based upon data, but things change all the time. It's not just that things change, it's the rate of change. Who here has a son? A lot of people? Some young. My son now is going on 12 years old. My son changes every single year. I am worried right now about the rate of change between 12 and 14. My wife has no idea what's coming. She's just like, oh my gosh, now we have to buy 2 gallons of milk a week. I'm like, honey, you don't even know. That little boy is going to grow 6 inches one year. And so that rate of change, it's not just that he's changing, it's how fast he's changing at times. So let me show you this. It's the same temperature slide. These are temperature points over the last 100 years. If I draw this black line, which is the average across all those years, so you see a slope like this. That's a rate of change, and that's about that level. If I average across shorter time spans in the recent future, you'll see that rate of change increases. If I average over the past since 1971, that's the rate of change. So it's not just that we see some things like this changing, it's the rate of change. Those are two different things and two very important things for the impacts on our environment. Got it? Please go home with that idea of your son growing 6 inches in a year. That's freaky. That rate of change is a little bit freaky to nature. It's not used to that type of change. Okay, now I get a little animation for you all. So I'm going to show you a map. This is basically the same type of data. These are global temperature changes over since 1885. There's a scale here. When it's blue, that means it is below the average level of change. When it's red, it means it's above the average level of change. So you're going to see areas in Alaska, they're red. That's not saying that the red is warmer than the blue. It's just saying that the red is warmer than the average for that place. Okay, does that make sense? I'm going to hit the go button here, and I want you to pay attention to a few things. I want you to pay attention to what happens over time. This is about year 1900. You'll see different areas of the country popping up. Climate change is not the same every place around the world. You're going to start seeing a rate of change as we hit the 1960s and 1970s when David Bowie was singing. I don't know if it's a coincidence or not. But you're going to see areas that get warmer and warmer and warmer. The rate of change and pervasive warming across all places. You want to see it again? Yes, okay. I was just joking about the David Bowie thing. I have no idea. I'll shut up this time. So the red temperatures, I said I'd be quiet, but I won't. Red temperatures are higher than the 1951 to 1980 baseline average. So we took an average there. Red is higher than that. Blue is lower than that. And again, this rate of change happening right about now. All right. So I told you about some global things. What about some Michigan things? And I'm going to give you a slide or two on that. I wanted to talk about, we have, everything I showed you is in the past. Those are observed patterns. It's not a model, it's not a guess, it's not a prediction. Those are what have been seen and what have been recorded. Now I'm going to talk about some projections to the future that do take into account, that are made by various modeling exercises that talk about our global climate. So in Michigan, what is expected to happen by 2050? Well, we expect warmer temperatures between 1.8 and 5.4 degrees Fahrenheit. And again, we see a range of variability. I'm not going to tell you it's 2.61265. We see a range of variability because we can look at different models and we can kind of average across those models, look at the range across those models. We'll see warmer winter nights. We predict more intense weather events, more precipitation likely in the winter months and likely in rain, not as snow precipitation. And for the lakes themselves, we'll see increased temperatures and less ice. So the climate we have in Michigan today that we think about, by mid-century, it might look something like the current climate is here. And by the end of the century, it might look like something like the current climate is over here. Okay? That's what we expect to see in Michigan. No value judgment here, good or bad. This is what the models predict. We can accept it or we cannot. But we better, and me, again, as a natural resource person, as a conservation person, I better think about this in my business, and I hope you all think about it in your business. Time out. I want to get to some jargon. I realize I've said a lot of things. I want to talk about a couple things that I just, so this is all side note. This is not the talk, this is a side note to the talk. Mitigation versus adaptation. You hear this jargon, mitigation. Mitigation is trying to reduce the buildup of greenhouse gases in the atmosphere and slow the rate of climate change. This is where you hear about things to try to reduce your carbon emissions. That's mitigation. That is intended to slow or stop the rate of change. Okay? I am talking predominantly today about adaptation. Adaptation are the adjustments in the human or natural systems that allow persistence or function under those changes. Okay? So given that there are changes, what do you do? Is what adaptation is. Mitigation is how do I slow that rate of change? I am only today talking about adaptation. The Nature Conservancy does sometimes work at mitigation. We do that at a global level. We tend not to do that work at a state level because at a state level, it's really the adaptation work that is much more, makes much more conservation sense for us because we want to make sure, that, again, that our natural systems are robust and resilient well into the future. All right, weather versus climate. I always go to my nephew's Facebook page and see his friends say, well, it snowed today in April. That means there's no climate change. That's weather. Weather is individual day-to-day atmospheric events. Climate is the statistical average of those events. So weather is short-term and chaotic and thus inherently unpredictable beyond a few days. Climate is a long-term average weather and is controlled by larger forces such as the composition of atmosphere and is thus more predictable on long time scales. Blah, 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 blah. Weather determines, my little girl comes down to me every single day and says, Dad, what's the weather going to be? Can I wear shorts? And I say, I don't know, honey, go outside and see. And she says, no, Dad, go on the iPod and hit the button and tell me what the temperature is. And I say, I don't know how to work the iPod. But weather is what determines what clothes you wear today outside. Climate is what determines what your wardrobe looks like. Okay? If you live in a nice warm climate, you're not going to have a bunch of down sweaters, vests, jackets, right? If you live in a cold climate, you will. But in that cold climate, it might be a really nice warm day, honey. You can go wear shorts to school today, which she did yesterday, and she wore capris today because it was kind of cold. And, so there's that. Okay, last one. Don't read any of the words on here, but you hear people, when they talk about climate change, talk a lot about uncertainty. It's like always, well, there's this and this and this, but there's a lot of uncertainty. There can be uncertainty at all kind of levels. All of these arrows and diagrams and spots on this graph are something about our climate system that will fluctuate from year to year, from decade to decade, from day to day even. So there is uncertainty there. I don't know what's going to happen tomorrow at these places, okay? Then there is uncertainty about how all those things impact the natural systems that I care about. How do those things impact bird populations? Are bird populations going to be tightly linked to those in one year and loosely linked to them in the next year? I'm not sure. It's a bit unpredictable. And then there's the uncertainty of what I am going to do in response to all these things. Am I going to build more windmills? Am I going to rely upon biofuels? Am I going to build another power plant? Am I going to build a whole new city? Do I lose population in this part of the world? Do I gain population in this world? So there's uncertainty there. So when you hear about uncertainty, we can't have precise predictions. about any of these things. We need to embrace that uncertainty, right? I'm talking about embracing uncertainty and embracing variability. Man, that's hard to get your arms around. Okay, time back in. We're back to the talk. So we got a problem, and this is the problem that I think about every single day. Within the Great Lakes region, observed and projected rates of climate change pose a major challenge to the natural resource managers, to policymakers, and to conservation practitioners as they strive to restore and maintain biological diversity and protect healthy and natural systems upon which all life depends. Simply, our conservation work simply cannot rely upon the assumption of a stable climate. I am silly. I will waste my money, I will waste my time if I make that assumption. I will be much more efficient if I understand the variability that exists now and may exist in the future and build and manage and protect the systems that I care about to handle that. That's what I deal with. All right, another great philosopher, Richard Dawson. We did a survey to try to understand how organizations like ours think about climate change. So we did this great conservation planning process that Bob here in the room was involved in. We went back and surveyed coastal managers, city officials, municipalities, natural resource managers, state employees, federal employees, all around the Great Lakes. We sent a survey out to 1,200 of them to try to understand what they understand about climate change, where the limitations, the level of knowledge, the current state of the state. We got responses from about 500 individuals around the state. And the survey says, climate change and adaptation are on our minds. These 500 respondents, again, which represent an average resource manager that deals with coastal issues or lake issues, 80% of them think about climate change on a weekly to monthly basis. They understand that climate change is important for their work and will impact their work. 80% of them, okay, that's a lot. That is most of people out there realize they need to be thinking about climate change. Good, I'm happy, that's a good thing. But we're a bit confused about the science. 50% said they're not quite sure they understand the science. All the climate changes, all the impacts of those changes, and the ultimate things that we can do about it. All right, there's an opportunity for education there. If only half the people, 80% of the people know there's something to be thinking about, but only half of them really kind of understand it, we need to do some education. And even worse, this is what scares me. Only about 25% know what to do with the systems they manage. So even though 80% see the problem, only 25% know what to do. We gotta close that gap. And I'm gonna be a little dissatisfied or a little scared until we do close that gap. It should be 100% are thinking about the problem and 100% know what they would do. That's a goal that we gotta try to achieve. So what the heck do we do, right? We've got projections, we've got philosophers, we got crazy maps, we got Richard Dawson, we've got debates, we got projections that look at the rate of change. It is confusing. And sometimes I feel about this old when I try to conceptualize all of that. I don't know what to do. Guess what? I'm going to tell you what to do. And I'm going to give you some examples from the Nature Conservancy. So first, the geeky side of me. Again, I'm an ecologist. I'm a scientist. I spent a lot of years in school that my mom and dad warned me about. But we tend to think about this concept of ecosystem services, the value that nature can provide, the value nature provides in and of itself, and the value that nature provides to society. And we tend to classify things, right? And I put things into provisioning services, right? Nature provides food, fresh water, fiber, genetic resources. Nature regulates. It's the benefits obtained from the regulation of ecosystem process. It regulates climate, it regulates disease, water purification, pollination. Nature has cultural services, right? The spiritual services, a sense of place, where we belong. The aesthetic, the inspirational, the educational things. We find ourselves in a great museum here. Nature provides many of those things. And nature also provides these things, these supporting services, right? Soil formation, nutrient cycling, all the boring things you learned about in the first chapter of your ecosystem biology class that you probably maybe took, maybe even in high school or college. Nature does all of these things. It does it unto valuing nature itself, but nature also provides all these things. CocaCola finds itself right here. Levi Strauss, right here where the fiber is. They like cotton. Nature gives that to them. And they need to make sure that nature exists in a healthy way to keep providing those services. I'm partially interested in that. I have stock in some of those companies. I'm sure it's represented in the mutual funds that I own. But I care about all of these things. I care about what nature provides and what nature partially gives to me. I'm selfish. But what I care that nature exists. So I want that as the background. because this is the work that I do every day. So what do we value? And I'm sure every single person in this room in Michigan has been to Michigan's forests and gone up north and watched the leaves change, or hiked around or went canoeing up in the Two-Hearted River. I hope that everybody's been to our wonderful coast, and I'm sure they have. When I grew up in Ohio, we did a trip of Michigan and the Big Winnebago with all 9 of my brothers, or all 8 of my brothers and sisters in one Winnebago. And I have a video of me back when I was yay high running down the dunes at Sleeping Bear. And I went back the other day in the parking lot, it was exactly the same. We all care about these river systems, and we all care about the agriculture. Michigan is the second most diverse agricultural state in the country behind California. Did you know that? That's a fascinating statistic. We produce the second most diverse amount of crops, given all of our fruit crops, given all of our mucky crops like sugar beets and carrots and things, and all the corn and soybean. We have the second biggest diversity of crops in the country, right behind California. Cool, that's really cool. We value these things. Every single one of us in this room has gotten something out of all these systems, and these are the systems the Nature Conservancy cares about. So, a few reminders. I want to step back. So if I am worried about those systems, if I care about those systems, what do I need to be thinking about in terms of the climate change impacts? Well, forests, what do I think about? Well, temperature change is going to influence forests. Drought stress is going to influence how trees grow. Disturbance regime, like the frequency of fire and pests, is going to be influenced by changes to our climate, how much precipitation, how much drought stress there is. And pests and pathogens. Again, we've heard a lot about pine beetles out west that are decimating some of the pine forest out there. Watersheds. Well, why do I need to be thinking about climate and watersheds? Well, there's increasing intensity of precipitation that I talked about. And there's temperature, and there's high potential for maladaptation. What does that mean? Well, if we have increased precipitation in the winters of the year, that's when the fields are bare because there's no crop in it. We're going to get more of that sediments and nutrients running off into those streams we care about. And we're going to see algal blooms downstream like we have seen in western Lake Erie Basin last year. Coastal systems, see all of the above, plus increasing water temperatures, increasing eutrophication, increasing toxicity, increasing and decreasing lake levels beyond what we see as the average, and decreasing ice cover. If we have less ice cover on the lakes, there's more evaporation in the winter, there's more potential for those lakes to go down. So I want you to be thinking about that, because I'm going to go through an example for forests, an example for watersheds, and an example for coastal systems. Does the tiger start yet? Okay, we're almost there. Forests. The Nature Conservancy owns some wonderful property up in the Two-Hearted River watershed, the Great Two-Hearted River watershed. We own 23,000 acres, and on that acreage, we cut trees. So that might surprise some people. Many of you do know that. But we cut trees on those properties. And we cut trees on those properties for 2 reasons. Ecologically, it's the right thing to do. Why is that the right thing to do? Because currently, those forests are about 90% sugar maple. They had been managed for sugar maple over time before we purchased them, which was the right thing to do for that industry. They could sell sugar maple. But as a conservation owner, that doesn't make a lot of sense, because if the sugar maple pest comes tomorrow, bam, we're screwed. Oops, sorry. We're in big trouble. So we want to cut some of that sugar maple out and promote the growth of other species. And that sugar maple is not just 90% sugar maple, it's all 40 years old. So it's like a big square box of sugar maple. It all looks the same. That's not necessarily good, right? You want young trees, you want old trees. So forests can be vulnerable. Climate change will amplify many of the existing stressors to those forest systems, like I just talked about. Many tree species won't be able to colonize new areas because there's insufficient rates of migration to keep up with those rates of changes in temperature. And many contemporary and iconic forms of recreation will not be quite the same in our forest systems. We're seeing that now with the snowmobile industry, and less snow cover in the winter times, or unpredictable snow cover, or very wildly fluctuating snow cover, snows and melts and snows and melts. So what do we do? What is an adaptation that is smart for nature in general, but also very smart if we think about some of those impacts of climate change? Well, sustainable forestry. We can cut trees. This is one of our forest advisor, and one of the harvesters out there is John Fosgate, who you're going to hear and if you come to this series in a couple, or I think next month. He's going to talk about this project, and he's going to talk about how we're trying to get more diversity into that forest. Diversity in composition, which is which tree species live there, and also diversity in the structure. So we do things, don't read this please, but just know that it's complex. We measure all of these things about the structure and the composition of the forest. We measure how many live trees there are that are small, how many live trees there are that are bigger than 19 inches, how many snags. Snags are standing dead trees. How much desirable new seedlings we have colonizing, how much dead wood there is laying on the ground that keeps all that moisture in the soil and the forest floor. We measure all of those things, and we know when we get to these numbers down this bottom road, we're in pretty good condition. We're in a highly diverse system. We've got to where we want. But you know what we're also measuring that I don't show you on this graph? We're measuring the outreach that we do in that forest, where that timber is being sold, who cuts it, are they local, is it being used in Michigan? And we measure the dollars that we're getting for that forest. We want to be in the black ecologically, and we want to be in the black economically. And if we do those things, that forest will be able to handle any type of change that we see in the future. It'll be able to handle increases in temperature because we have the trees in there that are robust and rely upon those temperature regimes. We know it might be able to handle increases in precipitation because we have the trees already there that can handle that. And maybe we have to underplant with some tree species that are kind of rare there right now, but might be common in the future. That is a smart thing regardless of climate change. It's an even smarter thing when we think about changes that might come 100 years down the road. All right, our coastal systems. I was lucky enough to be involved with the International Joint Commission, if you call that lucky, in the Upper Great Lakes study, very governmental study of looking at lake level changes and how we're responding to lake level changes, particularly in light of climate change. Again, don't read all these words, but I want to show you a couple things. What I really like that they did in this study, and I was a part of it, was fascinating. They looked at all the different water user interests. So these are all the stakeholders that use water of the Great Lakes. Municipal uses, commercial navigation, hydroelectric generation, ecosystems, coastal wetlands, the coastal zone like the municipalities, recreational boating industry. And they asked, when do you care and why do you care about lake level fluctuations? And here's all the reasons they care about. So let's just take one. I'll go to the recreational boating here at the bottom. Recreational boating and tourism can be adversely affected by both high and low level water conditions. For example, persistent low water levels can affect the quality of beaches in an area, as well as limit use of some marinas and limit access to the lakes. High water levels can cause some flooding of boat launches, right? So they need to be concerned when they manage those recreational facilities about where lake levels are. And not just where lake levels are and where they have been, where they might be in the future, given all those changes that I talked about. And if they're starting to make investments now that are ignorant of those types of changes, they might have wasted their time and money 20 years from now, 30 years from now, 50 years from now. For example, you're seeing all kinds of updates to our sewer systems right now, right? They have to make conscious decisions about the size of the pipes and the size of the storms that might come that they can handle before they have an overflow, combined sewer overflow problem. Because those investments, hopefully that infrastructure lasts for 100 years. I hope it does. So I'm showing you all this. I'm going to show you this is where I'm going to get geeky on you. Please follow with me as much as you can. But here are two graphs, two bars. And they went and asked environmental, coastal wetlands. Think of this graph as coastal wetlands. They asked, coastal wetlands, at what lake levels are you feeling good? When lake levels get too high or too low, when do you start to worry? And when they get really high or really low, when are you absolutely decimated? And then we could go ask the shipping industry the same question. Shipping industry, when are you feeling comfortable with lake levels? What range of lake levels can you deal with? When do you start getting out of your comfort zone? We call it a coping zone. You're a little bit worried. Maybe you can carry less cargo. Maybe you have to wait to get to a port. And when can you not operate? And luckily, there's an overlap in there of when it's good for those guys and good for those guys. Okay? And what's really cool is I want to show you a couple things that are interesting here. You notice there's a bad spot right here. If lake levels are always the same, it is not good for coastal wetlands. Coastal wetlands need that change. Remember I started off at the beginning. Our environment is built upon change over time. Those coastal wetlands need those fluctuations in lake levels, and if you're always the same, the coastal wetland doesn't provide the same functions. It needs that disturbance. It's a disturbance-driven system. These folks are just fine. But there's nice overlap. So I just want to show you that. Just an example of how we can think about different components of society, different industries, different user groups, different sectors, and try to look for the commonalities across those things. So what do I do about this? Well, what do I do about lake levels, right? Well, the thing that was recommended in this study is that we can work with this regulation of Lake Superior. And if we have a monitoring scheme in place around the Great Lakes where we know where we're getting down in lake levels that are less than 182 meters above sea level, if we know we're down there for a year or even a prolonged time, they can change the amount of water that is regulated at the outflows of Lake Superior. Now, that's not going to solve all of our problems, but it can help abate some of the problem. Or if they know lake levels are getting really too high, and they've been high for a sustained number of years, they can let more water through the system. Okay, that's one adaptation. And these models all include the potential impacts of climate change over time. Coastal adaptation, we own a property, the Nature Conservancy owns a property just north of Toledo. We own a couple thousand acres called Erie Marsh, and we manage that system. And that is a diked system of wetlands and a little bit of open water. So it's all diked, and we have a pump at the end. And that pump is about, 50, 60, 70 years old. And it goes, eek, 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 eek. And that pump has to pump water like 2 miles away, and it takes days. It's old, it's a little bit run down. The dikes are not pretty. They don't know what they do. They don't do what they're supposed to do. Fish can't move from the open lake into the dike system to spawn because there's no fish passage. We got some problems. We got a whole lot of funding to update that whole dike system, update the pumps, and update it for fish passage, which is great. But we need to think about lake levels when we're doing that. Because if our pump is placed at a place where lake levels are probably predicted, we don't want some year the lake levels to be down there and the pump to be up here. That's a problem. So we need to design these types of restorations that we do in mind, thinking about what's going to happen at lake levels in the future. How much can they fluctuate? What is the impact of climate change on those fluctuations? So for example, this heron right here can only feed in waters that are less than the length of its legs, right? It walks around on the ground. And it won't go to places where water levels are too high. Shorebirds need open mud flats to feed on, and they won't go where there's this much water. And so we want to be able to provide certain levels of water for those species any time of the year, any time of the season, whatever season it may be. One other thing I forgot to mention is we also have to think about these restorations with the invasion, or with new invasive species that may be here because it's warmer or because they can handle the milder winters. And so we have to have early detection monitoring schemes in place to be able to understand when these species are moving or colonizing a new area, and we have to have rapid responses to those, both terrestrial species as well as aquatic invasive species. Heard a lot of talk about Asian carp. Asian carp is not the only one. We'll have another series lecture on Asian carp, but it's not the only aquatic species out there we need to worry about. There will be something else tomorrow. There'll be something else next week. There'll be something else next year, just theoretically, hypothetically. So we have to think about climate change, how climate is going to make our region more suitable for those types of things, and we have to have an adaptation here for coastal systems. We have to have these early detection and rapid response plans in place. Okay, how's everybody doing? Good? We're almost there. Our water systems, our waterways. This is the Paw Paw River. Has anybody been down to Paw Paw wine tasting or something like that? Wonderful place, and you go on the Paw Paw River, and there's places down there where you feel like you're just in the middle of nowhere because it's got a nice bottomland forest, and the river is beautiful, and you don't think of that as you're driving through that part of the state necessarily. So this is the Paw Paw River. We have some issues with runoff in the state, and this is the picture from last year. I think it's August of 2011. And this is Lake Erie here, right? Detroit, Lake St. Clair. This is Western Lake Erie, Toledo here, Cleveland over here. I grew up in Conneaut, Ohio, which is right about here. This green here is an algal bloom. It's a harmful algal bloom. It's not a normal state. This is in August. You can't go swimming. Nobody could go swimming there right now. If somebody went out there and dipped their hand in the water, it'd be like pea soup. It'd be like an algal bloom, bloom of algae. And it's harmful algae. If dogs go in there, and they might perish because of the toxicity of the bloom. Right? You don't really want to go walleye fishing. You don't really want to go to the beach. Right? That has an impact. Ecologically, there's an impact, and economically, there's a big impact. Part of this problem is due to a lot of runoff of nutrients and sediments from the Maumee River watershed, which is a big watershed, one of the biggest watersheds in the Great Lakes, from our agricultural fields. We put nutrients on those fields, and we need sediments on those fields to grow the crops that we use and we care about. So we need that, and we do that for very good reasons. But we also have to understand the potential impacts on the aquatic systems we care about. And one of those impacts is this, down here. Now, the thing is, you know what, this year, this didn't happen. You know why this didn't happen this year? It was really hot and dry. We didn't get that much rain in the springs of the year. A lot of the fertilizers are applied in the springs of the year. Sometimes they're applied the winter before. We didn't get that much precipitation. We didn't have that much runoff. There wasn't as much sediments and nutrients entering the system. We didn't see this kind of algal bloom. This is one of the biggest people have ever seen ever. All right, I'm going to get a little geeky on you again here. What does the Nature Conservancy do in agricultural environments, you ask? What does the Nature Conservancy do in agriculture, you ask? We do a lot of things, and you normally think of us, again, as our nature preserves, but we work in these three watersheds, Green Bay, Saginaw Bay, Western Lake Erie, and Paw Paw. These are predominantly agricultural systems, and we work there because we care about the impacts of the natural systems. So we actually work with farmers to help them implement practices on their fields that are good for their production and good for the environment. Things that you hear out about, like cover crops, or buffer strips, or riparian strips along the waterways that intercept the nutrients coming off these fields. We work with these farmers to decrease the levels of nutrients and sediments that are entering our waterways. And we're asking a question about how much is enough. We see some problems in these landscapes, like erosion and runoff, that bring these dirts and sediments into the stream. We implement practices like filter strips, where water tends to run the most, so it's not carrying those sediments with them, or riparian buffers. And we want to see these types of healthy systems. So we have to ask a question, well, how much is enough? How much of these practices in the middle here do we have to do on a landscape to make sure our systems are healthy? How much do we have to do today? And how much do we have to do tomorrow when we think about increasing precipitation? So, oh boy, I'm going to give you a case study. And I'll try to make this as simple as I can. We looked at the Cass River watershed, which is up here in Saginaw Bay. This is Saginaw Bay. This is the Cass River watershed. I'm going to try to walk you through this graph, so please bear with me. On this axis over here, we have the amount of phosphorus. Too much phosphorus entering the system from our nutrients we're adding to this field, the fertilizers, is not a good thing. It hurts the system. We don't want high levels of phosphorus up here in the red. It's okay. We're happy if our phosphorus levels are down here where it's green. Green good, red bad. That's all I want you to know about that axis. Across the bottom here is how much of the farm area in this watershed is under some type of good conservation practice. How much has an agricultural best management practice on it. So it's how much land is being managed, still to produce agriculture, but is being managed in a way that is kind to the environment. Okay? Here's our current scenario, is this blue line. So right now, this amount of, I think it's somewhere in this range, amount of land is in current conservation practice, and that's the amount of phosphorus that's entering the system. We're doing okay right now. And we ran a model to kind of look at this, a mathematical model. But you know what? We ran another model looking at the predictions of climate change into the future, looking at our precipitation levels into the future. And that's these other three lines. So these are other kind of variables. They're different iterations or different scenarios of what might happen with climate in the future. I'm not going to explain all the details. But I want you to see, to get into the green, we have to have over 50% of the landscape in some type of conservation practice for those farms. To get the same benefit over here, we only need 10% of the landscape. So think about that for a second. If we think about climate change and our best knowledge of what might happen to climate change in the future, we need to 6 times the amount of practices in the landscape than we currently have, just to be at the same place. Let that sink in. We need to do 6 times as much just to be at the same place if these predictions are on or even close. That's kind of sobering. And we can start to put some dollar values on those because we know how much it costs to implement those practices. And if we don't think about that, our systems are going to be worse off than they are today. So, I gave you 3 examples. I talked about climate and our adaptation of forests. I talked about climate and our adaptation in coastal systems, and I talked about climate and adaptation in our agricultural systems. I don't want to be sad, I don't want to be scared, I don't want to be depressed. It's very exciting because we still get all these services out of these systems that we care about. Every single day, we all still get these services. Again, whether it's my business of conservation, or your business, or your town, or your municipality, or your drinking water. Our systems are in good shape. Please, 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 we do need to think about what our world will be like in 10 years, 50 years, 100 years, 200 years, because I'm sure we will want to get these same services out of the landscape. We want to promote these types of things, and we want to avoid certain types of things. So what can you do? What can you do today? Well, you can be aware. You can come to talks like this and understand these impacts. But you can bring these home to your businesses, your organizations, the local town planning you sit on, or the watershed council, or your corporation. And you can ask the question, how are we thinking about the future? I was able to chat with some folks at Dow Corporation about a year ago, and they plan 100 years into the future. They're thinking about what their businesses will look like 100 years from now. I'm thinking about what my business will look like. You all can go ask them about what your town, your investments, your businesses will look like in the future. You can also be very aware of your own impact. If you go to the Nature Conservancy's website, nature.org, you can calculate your carbon footprint and understand your impact. Because all these things are part of the solution, but conservation and using less and alternative forms of energy are also part of the solution. And we need to each understand our role in that and the potential impacts that might have on nature. So, thank you. You are invited to at least 5 more lectures, and maybe we'll do this again in the coming years. All great, many of my staff and my boss, Helen, all talking about great and wonderful things. Please join us. Come learn more and start that path of education and influence. Nature.org is our global site. Nature.org Michigan is our Michigan-specific site. And we also have a Great Lakes climate site where you can go and dive all kinds of detail into climate change and the work we do in climate change. And how are the tigers doing? Sorry. But thank you very much. I'll be happy to take some questions, and then we have some time to go outside and answer questions. So I'll be happy to take a few questions now, and then we have some more time afterwards if people want to mill about outside to ask other questions. I'm sorry, that light keeps bothering me. Yes?
The planting zones are changing.
Yes.
Should we be thinking about moving trees?
Yeah, I did have a slide in here earlier that's showing the plant hardiness zones that you get from the USDA every year that tells you when you can plant plants and when you have to worry about freezes. If you look at those maps, they've changed. They had to update those maps because the hardiness zones have changed. Personally, you have your own gardens, and some things may or may not do so good in your lifetime. And I manage my garden on a scale of a couple decades. I may not live that much longer than that. But people are asking the question, wow, should we be helping species move around? And we do ask that question a lot, particularly with a lot of species like there's some butterflies in this part of the world that sometimes people translocate, or they call it assisted migration, because the intervening landscape is no longer wetlands or natural cover, it's a city or a town, and they can't get from this spot to that spot. So sometimes people do consider it actively managed for that. And a lot of times it's tree species as well, and that is going on as we speak. So a lot of people do consider that, and that's called a relocation type mechanism or adaptation that we can do. If we see that a species has no way of getting from point A to point B over time, then that is viable option, and that does happen particularly with, I've seen it in a lot of cases in butterflies and tree species.
And everyone, I have a microphone for your questions so we can pick up your questions on the taping. So
can you still hear me well?
let me pass it to you when you ask a question. So Patrick, go ahead.
Yes, back there, in the back.
I'm just particularly interested in the one picture that you showed with the runoff from last year, the bloom,
Right.
the algae bloom. And is there anything in play right now that maybe the Nature Conservancy is doing that would help? I don't know. Are there any new laws being passed that would try
we're doing it. We have a whole agricultural strategy. I can give you some highlights. A big part of it is to really target these agricultural practices to the places where we will get the most bang for their buck. A lot of times right now in our federal agencies, They don't really target the practices because they're a federal agency and they can't favor one land over the other. So they just kind of welcome everybody in the door. Whoever comes in the door, they may implement practices on their landscape. But we know where the most efficient places to place them. So we are working to help the federal agencies that write the contracts with these farmers to be much more targeted. We are doing that in the Pawpaw, where the Nature Conservancy is actually, we've received money from CocaCola, and we've used that money to help hire a person in the local conservation district that goes to the priority locations that we've identified in some modeling exercises. So there's that kind of thing. Right now, we're also testing some ideas of working with the supply chain, the actual fertilizer producers, to get them certified on how they sell their fertilizer, the rates of application, the amounts of application, the timing of application. So we're trying to work up higher in that supply chain with the producers of fertilizers to help educate them about those potential impacts, as well as make sure that they are educating the users. So we're involved in a lot of places all along, from the ground, on-the-ground practices, through the major funding mechanisms like the Farm Bill and the implementers of the Farm Bill, up to the private corporations that are involved.
Okay, and then one follow-up question is, do you expect, since we had a dry summer this year, if we get a wet winter season, do you expect that that will, in the spring, be as big as it was or bigger?
Again, you asked me to make predictions. I would not be surprised.
Okay.
Yeah, I think that's something we should probably get used to and hopefully start working to avoid. And many, many, many people are working to help with that problem, from our federal agencies, our International Joint Commission, the various universities. Many, many, many people are really focusing hard on this issue. Next. Yes, right.
There's a trend now in small communities to pump water from lakes to water their, Thank you. There's a trend now among small communities for irrigating, their lawns and shrubs by pumping water from adjacent small lakes. How do you feel that will affect the water supply in those little lakes? Do you have any idea on how do they feel that this is a good idea? Because water costs are going way up.
There's a number of things we're worried about there. And again, I don't know those particular instances, but I gave you some examples of our, if you drove around the Midwest this summer, you looked at corn, it was not knee-high by the 4th of July. It was barely knee-high by like October and September. The corn, we did not have a good year for corn. If you were down in Illinois, it was devastating. What we start to think about is people are going to probably start irrigating in places where they didn't used to irrigate. And that's what I was talking about, that uncertainty in human behavior or our response to these changes. We might see a whole lot more irrigation in Michigan. You don't see a lot of irrigation in Michigan, not that much compared to, go out to Nebraska and things. So those types of impacts, we need to start worrying about our systems and what that will do to groundwater, how that's going to lower lake levels, that it's going to have, again, a nature issue, but it's also going to have a recreational issue. How all those little lakes down here in southeast Michigan, all those wonderful little lakes down in southwest Michigan, they're all going to be impacted. My father-in-law has a pond, and he swears it's going down because the guy next to him is irrigating his farm fields. So those are all considerations when you think about what is the total water usage, who are the water users, how much are they using. And we do have some wonderful tools in Michigan developed by Michigan State University in the state that looks at water withdrawals and approves certain water withdrawals at certain levels. It's very much an issue. Yes.
One of your slides showed 3 large watersheds and then the Pawpaw watershed.
Sure.
How did the Nature Conservancy choose those to focus on? I mean, what criteria did you use? And will the watersheds that you focus on change in the future as your strategy or the criteria change?
Excellent question, just right at my heart. We start, I won't go into too deep, I'll give you the short version. We go through a process of planning we call conservation planning. And the very first thing we do is say, well, what do we care about? What are the kinds of systems, the species, the types of wetlands, the types of forests, the functions that they provide to nature and society? And so we actually list those. And then we ask, what's our goal for those things? How many do we want? Where do we want them? And we actually go through a suite of analysis to highlight places on the landscape that if we do some type of conservation, it'll benefit those things we care about. And so that's how we end up with maps like those ones. Those are places, if we want to work to conserve the Great Lakes, we need to be working in Saginaw Bay. And we work in Saginaw Bay not just for the bay and for the lakes, but we also work in Saginaw Bay watershed because there's some wonderful biodiversity there. Shiawassee National Wildlife Refuge, if you all have never been there, go there. It's an incredible place. With that and state land, it's like 40,000 acres out there in the middle of Saginaw Bay. That is incredible biodiversity. So we select those places through a very kind of scientific planning process. And those do tend to change. And again, it's not that we're out there to do land acquisition across all those places. We're out there to implement the right types of conservation, whether it's agricultural practices or forest practices or land acquisition or help co-management with state lands or private landowners, all of those things. If we can influence those places, we feel good that they will do the conservation, they will help us achieve our conservation goals. They do tend to fluctuate over time. It's not just biodiversity that drives that. There's opportunities. There's political considerations that may weigh one place more than another place at any given time. So they do tend to fluctuate a bit over time, but our core areas tend to remain areas of focus.
Why don't we take one more question, and then there'll be time to visit with Patrick afterwards. So is there one more?
Sure, right
Patrick?
here.
Pass it.
Is anybody looking at how climate change is affecting the ecology of the inland lakes?
Of inland lakes? Absolutely. We here, the Nature Conservancy of Michigan does not work so much on many inland lakes. A lot of our work, we look to partners to do that. In Michigan, there's a lot of work on inland lakes across all of Michigan, Wisconsin, Minnesota, I mean, regionally, but there's as much of that. These are the lakes, states with 10,000s of lakes, 30,000, 40,000, more than that. So a lot of other work around here is kind of looking at those, and it gets a lot of those impacts of water withdrawals on those lakes, surrounding land use on those lakes, and the impacts of the kind of net supply, precipitation, and runoff, good runoff through the watershed to those lakes. We're not so much involved here in Michigan on those, but there are lots of other organizations and agencies that do that work.
Won't the climate change affect the turnover?
It affects, so within all lakes, there's what we call turnover, a seasonal turnover, where the cold water and the warm water kind of switch places in the springs and the falls of the year and keep those lakes turning over. Climate changes have impacts on how frequently things turn over and the degree to which they turn over and the kind of the bottom layer of the lake, which is less oxygen than the topper part of the lake. And they're also on these inland lakes, there's a big impact of ice cover on these lakes. And you see much discussions about the impacts on ice fishing and winter recreation and snowmobiling and pond hockey and all those other things that are fun to do. So you see kind of both those ecological impacts as well as the recreational and economic benefits too.
I know you'll all agree with me that Dr. Doran just set a very high bar for the remainder of this series. So, Patrick, thank you very much.
Thank you all.
And simply by way of housekeeping for you, I will give you fair warning that even before this talk, this series is now halfway sold out for every lecture all the way through the spring. So I hope if you are pondering buying the remainder of the series that you will do so soon. And we're also grateful for your help. Mouth to mouth is the best kind of advertising that both the Conservancy and the Institute have, and I hope you'll tell your friends about this, but please get your seats for the upcoming talks because we'd hate to have you be disappointed. Also, I can't tell you how they'll be used on the Conservancy side, but we did videotape the lecture this evening. It will be available off of the Institute's website in our online resource section, and it'll be available approximately a week from today. And we're grateful again for your coming, and I want to thank one last time our Northern Trust friends for all the help in making this possible. So thank you for your time tonight. And it looks like this, and you can buy your tickets right now at the front desk. So thank you.